Good morning, grade 5s and 6s. It's nice to see you today. So this presentation is actually really important. I'm talking specifically about pictographs, but everything that you learn in this about how to manage data, how you think about data, this continues to apply on all the other types of graphing that we're doing, okay? So this is a really important one. I know sometimes you guys get bored partway through the lecture and you just skip over, and I get that. It's a long time. I get bored of talking that long. I do, okay? But everything I'm talking about here is important. So please try to bear with me, watch the whole video, and we'll see if maybe we can solve some of the issues that seem to be chronic problems for some of my students, okay? So I'm going to just take my face off now because I need to lay down my screen so I can write on it. All right, so we're talking about pictographs today. This obviously right here that we have in front of us is an example of a pictograph, but we're not going to start there. We're going to start here, okay? So pictographs are something where we use pictures, where we use pictures to represent data. Represent means stand for or demonstrate data. Okay, so when we're drawing a pictograph, what we're doing is we're going to have maybe a line here, and then maybe, well, let's make circles, okay? This is an example of a decently good pictograph, okay? It's not perfect. I'm not as neat as I wish I was, okay? But it's not bad. All right, now this over here is an example of a terrible pictograph. You see the difference? You see how nothing is lining up properly? There's some big spaces, there's some little spaces. It's really hard to read that one. Whereas on mine, you can see those are all kind of in a row, those are all in a row, those are all in a row. Up and down, they're in a row, dot, 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 dot. See that? Okay. Now, obviously, I haven't written on information here, so maybe this is hats, and this is scarves, and this is caps, and this is, I'm trying to think of other headwear. This is a cowboy hat, and maybe this one right here is a sombrero or something like that. So we're talking about hats in this particular graph. Okay? So that's one way of looking at this data. All right, so the first thing is when you draw a pictograph, I expect to see some equal things happening, okay? The second thing about pictographs is that they're representational, all right? I already highlighted that up at the top here, and I'm highlighting again. It means it's standing for something else. A graph is always representational, okay? Now, the third thing is you'll notice in a couple places I did this, which maybe just looks like a really badly drawn circle, but it's actually not. Because when we talk about representation, maybe one circle equals 10, which means hats equals 10, 20, 30. That equals 30 hats, okay? So if a full circle equals 10, then what does half a circle equal? Well, it equals half of that, right? So 10 divided by 2, which equals 5. So a half circle is 5. So now if we wanted to figure out, well, how many cowboy hats do I have? I have to go 10, 20, 30, 5. So cowboy hats is 35. Do you see that difference? Now, in this case, I said that the circle represented 10, but it doesn't have to. It might represent something else, and you'll see that on the next one, okay? Now this next note is just a general kind of note. How many more is not addition? Most of you want to do that as an addition. It's not an addition. So if I ask how many more hats there are than scarves, hats than scarves, hats is 30, scarves is 20. So how many more is 30 minus 20? The answer is 10 more. Not 10 hats, not 10 scarves, 10 more. And we're going to do another example of that as well. And then how much do you represent? This last question here, how much do you represent when drawing your own graph? That's going to be the last thing we talk about. So we're just going to not talk about that right now. Okay, so now let's go to some example graphs. So here we have an example of what people's favorite donuts are. All right, so far so easy. What is the average number of donuts purchased? Now you already know what an average is. An average is a mean. So how do we find that? Well, the first thing we do is we take a look at our graph and we notice this. This is important. Okay, that means that this is not 1, 2, 3, 4, 5, 6, 7, 8. This is not 8. That's wrong. This is 16. And they actually help you out on this one by showing you over here what the numbers are. Okay, but it's very, very important that you don't count each one of these as 1, 1, 1. Okay, so that one's 16. This one's 20. Oh, whoops, that's the wrong color to be writing with. Let me write it over here. 20, 16. All right, and remember that's because this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, because every donut is, or every round thing is worth 2. All right, so original comes to 15, chocolate is 8, frosting is 17, and jelly is 12, which you already have over on the other side. So remember that when you're doing an average, you have to add all of this together. Wow, that's really messy. Let me fix that. All right, so 16 plus 20 plus 15 plus 8 plus 17 plus 12. And that equals 88. And then what do you have to do? You have to divide it by how many add-ins you have. So 1, 2, 3, 4, 5, 6 types of chocolate donuts. So divided by 6, this actually gives us a decimal number, but I'm just going to round it to the nearest whole number. So there's 15. The average is 15 donuts. Okay. Now, what if a question asked me how many kinds of donuts does the store sell? Well, the store sells 6 kinds of donuts. 1, 2, 3, 4, 5, 6. 6 kinds of donuts. All right, so an average is wanting you to look at the whole, all of the data, all of the numbers on here. I'm going to erase this in here now because you shouldn't need it anymore. All right, but now what if the question is instead asking us about one specific kind of donut? So in this case, it's asking about original donuts only. There's no other option. Okay, so we have to think about that. What's my number for original donuts? 15. And what's my number for adults? 10. See that? So 10. So now, how many children like original? If there are 15 donuts in total and 10 adults like it, how many children like it? That's a subtraction question. You have a total number of donuts, you take away the adults, and you get left with the children. That's how many kids like them. And we know that's true because 10 adults like original, 5 children like original. That makes 15 in total, which is what we want because there are 15 original listed up here. Okay? Now, how many more people like custard than chocolate? Again, we've got to think about what we need. We've got a custard and we've got a chocolate. What's my number for custard? Well, let's see. My number for custard is 20. What's my number for chocolate? My number for chocolate is 15. How many more? Means subtract. 20 minus 15 equals 5 more. Not 5 chocolate or 5 custard. 5 more people like custard than chocolate. All right. So now, when we look at here, this over here, I had 1 circle equals 10. Now when we go to the example graph here, we had 1 donut equals 2. And now we go down here and we have 1 person equals 4. Okay, so as we can see, representational data can change all the time. So we've got to keep that in our heads the whole time. Now the first thing I like to do on this is I like to give myself some numbers to work with. Okay, so this is 12 because 4 plus 4 plus 4. And this is 12 because it's the same. This one is 4 plus 4 plus 4 plus 2 because this is a half a 1. All right, which gives us 6. Whoops, sorry. Doesn't give us 16. Gives us 14. Then this one is 16, 16, 20, 24, and 36. Okay? And we can figure that out by 4 times 4 is 16. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 26. And 9 times 4 is 36. Okay? So we have 3 times 4. 3 times 4. This is 3 times 4 plus 2, because we had a half a 1. This is 4 times 4, 4 times 4, 5 times 4, 6 times 4, and this one's 9 times 4. And it's always times 4 because we have a representational data of 4. Why is this 9? Because I have 9 people here. This one is 6 because I have 6 people there, etc., etc., etc. All right. So now, what is the average school membership? We know how to do that already. Average school membership means we add up all of these numbers. That's why I like to have them written out, okay? So the answer to all of that addition is 150. So I go 150 from here, adding everything together, and then I divide by my number of pieces of data. So again, I've got 1, 2, 3, 4, 5, 6, 7, 8. So divided by 8. This also actually gives me a decimal number. I'm going to round to a 19. You won't have decimal numbers in your work for the most part. Okay. And then which club is the most popular? That's obviously math. What are some reasons why math might be the most popular? Well, that's hard to tell, but maybe they have a great teacher. That's possible. Okay. Maybe it's at the best time. In other words, maybe Monday is when everyone has time. Who knows when it is? So maybe it's got the best time. Maybe everyone just really likes math. That's possible, right? Okay. All right. And then again, the same question as last time. How many clubs are there at this school? How many clubs? There are 8 clubs. How do I know that? Because I counted all my number of clubs. All right. Then how many students like chess or art? Oh, now see, this is a different question than we've had before. Chess or art, those are our 2 words we want to work at. Okay, chess has 14 and art has 16. Now, when it says chess or art, what they're actually wanting you to do is add them together, which means 30 students like chess or art. And then the last one is the same question again as before, just one we're having to help you figure out. So, sports club, 13 girls, how many boys? Okay. First thing again that we have to do, sports club, 36. Okay. Then we've got 13 girls. Well, if they're not a girl, they're a boy, right? So we have to do the math. So we've got 36 and we've got 13. But how do we know whether we're adding or subtracting? Well, we know that the sports club has 36 in total. So that has to be our biggest number, which means boys has to be less than 36. So it's going to be a subtraction question, and we're going to get 23 boys like sports. All right. So here, the last thing we're going to talk about is making a graph. Okay. So now in this data set here, you can see that I have all sorts of different numbers set up here. Okay. And you can see each one of them. So first I have to choose how I'm going to represent my data. Okay. So since we're talking about the zoo, let's represent with a cat head. Okay. An animal head. Maybe that's not a cat, but an animal head. Okay. Now I can choose what that animal means. I could say it means 10. I could say it means 20. I could say it means 50. I could say it means 100. But let's look at these numbers and see which of these numbers kind of make the most sense for this data set. Every single one of these numbers will work. So the question is which one do I want to use? And I've decided I'm going to use 100. Okay. The reason I'm going to use 100 is because I don't want to draw too many pictures, but I want to do something that's fairly accurate. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay. So on Monday, I'm going to have to draw 5 1/2 cat heads. Why 5 1/2? Well, 5 would be 500, and a half ahead would then be the remaining 1. Okay, so this graph is going to have a bit of a problem. I've drawn it too big. I'm not going to have room for everything. Okay, so to draw my half head, I'm just going to draw a whole head, and then, oh, I can't do that. Okay. There's my half a head. Okay, and then on Tuesday I've got 600, so I'm going to do the same thing. Notice, just like I versed instruction, I gave it really neat. On Wednesday I've only got 400, so I'm going to draw 4 hundreds. Okay, on Thursday I've got 550, so I'm going to draw 1, 2, 3, 4, 5.5 again. All right, I know I didn't put all my ears on. We're going to pretend I did, so I don't have to make this video too long. 1, 2, 3, 4, 5, 6. Because 600, you need 6 100s to make 600. I forgot to put Sunday on. Saturday, I now have 1350. So that means I need to draw 13.5 cat heads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.5. And then on Sunday, I need to draw 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See how my graph worked? Now imagine if I had used this number instead. If I had used that number, then I would have had to draw 55 cat heads just for Monday. And then Tuesday, I would have had to draw 60 cat heads. So that's why picking what you use for your data is really important. Okay, so to finish off, I'm just going to show you the work you're working on. This is your workbook work. I'm going to help you out here with a couple things because there is some challenges. Okay, Niagara Falls, that one's easy. You've got some questions about inside and outside. Okay, Niagara Falls is a waterfall. Okay, the CN Tower is inside. Okay, Algonquin Park is a park, so it's outside. And the ROM is a museum, so that's inside. Okay, and this is just going to help you out with question number 4, where it's asking you about activities outdoors. Okay, and that should be all. Don't forget your representational data. These people are not one. This is not one person. This is, I don't know, you tell me. Okay, on this one right here, you're going to use this data to draw a pictograph in here, just like I did. Okay, so you're going to make a line here. You're going to figure out what your representation is. So you're not going to draw 150, and you're going to use one symbol. You're not going to draw a pizza for pizza and a salad for salad and spaghetti for spaghetti and sandwich for sandwich and fried chicken for fried chicken. You're going to draw one thing. So if you decide you want to use a pizza slice to represent this, then you use a pizza slice for pizza, but you also use a pizza slice for salad and for spaghetti and for sandwiches, etc., etc., etc. Okay? All right. This question, we haven't talked about anything like that, but if one order costs $7.99, then how much does the salad cost? So the first thing you do is, well, how many salad is there? There's 100 salads. So if one salad is $7.99, how much does 100 salads cost? Okay. All right, I'm going to end this video now. Good luck with the work. Grade 5s, you're working on this page, day 79 in your workbook. Grade 6s, you are also working on this exact same worksheet. It was sent to you a couple Fridays ago when we were sending the bus around, so please work on that worksheet at this point in time.